Hello, students. We are quickly going to go through some basic mechanics of the rock cycle in today's lesson. Our learning target today is I can explain how Earth materials are constantly being recycled and changed. Um, this is a big piece of understanding how planet Earth works, and why we taught you about rocks is to understand how they keep changing from one type of rock into another through some different processes. Let's start with igneous rocks. Um, Igneous rocks are formed, as we know, from volcanoes. So, how they're formed is melting happens first. The rock turns into a liquid like magma or lava, as you can see in these pictures. Then it cools and crystallizes. Um, what happens during the cooling and crystallizing is that it solidifies, it turns back into a solid, and you start seeing some of the different crystals, the different colors and different specks you see inside of the rock. Uh, where they form is very important to understand, so make sure that you are taking notes specifically on where they form as well as how they form. And they form wherever there's volcanoes. Now, it's important to understand that volcanoes are found, one, on the edge of plate boundaries, so wherever two plates are next to each other. We often find a lot of volcanoes around those spots. Um, and then lastly, there are these things called hotspots. These are volcanoes that occur in the middle of continents and oceans. Think like Yellowstone or Hawaii. These are places where there's magma or a magma chamber underneath the surface of the crust in that area, and every so often there is an eruption there. Or in the case of Hawaii, it's a very active hotspot, lots of eruption, lots of igneous rocks being formed from the melting and cooling. So let's move on to sedimentary rocks and how these are made. So these are the rocks that are made up of smaller pieces of other rock. And there's a lot to this, so make sure that you are taking good notes on the different steps of this. First of all, sediment. Small pieces of rock that have been broken down over time. These are the building blocks, the Lego, the ingredients of a sedimentary rock. And this can be sand, it can be mud, it can be silt, which is kind of like soil, gravel, and clay. The next step is we have to weather. So we've got to break down a big rock into these smaller pieces, these sediments. This can happen physically, where we break it down with force like water, wind, gravity, ice, another rock hitting another rock. Those are mechanical processes. Here's an example of freeze thaw weathering down here in the bottom. The last one is chemical weathering. This is where different chemicals break down the rock. There's a chemical reaction and it just starts to dissolve the rock away. This is like acid rain. When acid rain falls on like marble or limestone, it just kind of dissolves it away, like what happens when you put sugar in water. Cool. Now that we have small pieces, we have to go through erosion. And that means we have to move the sediment to another location. So we can have gravity pull it down to the base of a mountain. A river can carve and take all that sediment downstream. Rain can wash it down. Uh, all sorts of different processes are moving these tiny rocks to a new location. So we've got glaciers, which are like bulldozers. We've got wind, which like sand blasts everything and then carries the wind with it. This is why we have the sand dunes in Colorado. And then we just have general erosion where the sediment just washes away with water and falls down. Now, we've made sediment. In order to make the rock, we have to deposit somewhere. We have to go through deposition. If any of you are familiar with banks, you might make a deposit where you put something to let it sit. So this is when the sediment stops moving and it's deposited in flat layers. And if you recall, our youngest is always the top layer. That's the last one to be laid down. So you usually need a flat location for this, like a floodplain, the ocean floor, somewhere that's flat where these are going to stop and sit. Now, as they sit, they're going to go through compaction and cemented. This is when the rocks are squeezed together, and then the different minerals inside of them kind of come out and they glue themselves together like rocks, or not like rocks, but like glue, and Just like what we did with our Jolly Rancher experiment, as they got pressed together, the sugar just started to connect with it, and it became more solidified. And that's how you make a sedimentary rock. You go through some weathering, then you erode and move everything away. You deposit it and let it sit, and as it sits, these minerals come out and glue the tiny fragments together. Where they form is important to understand. Um, Unlike intrusive igneous rocks or metamorphic rocks, sedimentary rocks form completely on the surface of the earth. These do not get buried deep underneath the earth. These get buried on the surface where compaction happens. Um, these must be in flat, low locations. Think ocean floors, lake beds, canyons, floodplains. Anywhere that's flat, where that's not going to move for millions of years, is a great place to form sedimentary rock. So let's move on to our last one for metamorphic rocks. Sorry, guys. So metamorphic rocks, how they're made. Metamorphic rocks are made with extreme heat and pressure. I always call these the grilled cheese ones because I always throw grilled cheese on the stove, and then at the end of each side, I press down with it to kind of squish it down a bit. Um, these rocks need to form underground. Um, These are going to form in places called subduction zones, where one piece of a continent or a continental plate that makes up the surface of planet Earth is diving under another one. So it's a natural burial process. Another place that this can happen is underneath mountains. As mountains build up, there's more weight to push down and push it more towards the uh, center of the earth where all the heat is coming from. And as it pushes down, you've got gravity pushing, a little bit of the heat coming up, and that's forming our metamorphic rocks. So places that these need to form are going to be things like subduction zones where the earth is going down and underneath mountains. So we really want to bury these types of rocks. And that is the gist of the rock cycle. Please move on to the next step for the notes. You are going to be putting in a rock cycle diagram in your notebook. Step 1, open to the next page in your notebook. Step 2, draw a rock cycle diagram like what you see on the screen right here with igneous rock, sediments, sedimentary rock, metamorphic rock, and magma and lava. Include all of the arrows. 3, fill in the arrows for the processes to change one rock for another. So what process is going to turn igneous into sediment, or sediment into sedimentary, or sedimentary into metamorphic? Make sure that all these arrows are filled in. Add in additional ones if you feel needed. An example would be like this arrow going from metamorphic to sedimentary would be weathering and erosion because you have to weather and erode a metamorphic rock to get it down to its sediments. Add additional color or pictures to help organize your diagram. If there's multiple processes, color in those arrows with the same color to help organize what's going on. If you are someone who's visual, draw on maybe pictures to help show these processes. And lastly, raise your hand to show teacher to give or to get credit. All right, thanks everyone. Good luck. Raise your hand if you need help.